Good afternoon, Black Hat. Welcome to one of the final sessions of the day. Before we get started, just one big announcement. We would appreciate if you would put all of your mobile devices into some kind of silent mode. We are, of course, recording this talk, and so if there are too many interruptions, we're going to have to lock the doors and start the talk from scratch. I'm sure you want to get to dinner sometime tonight. There's only two things that you can't leave Black Hat without. One of them is a profound new knowledge of security and the things around it, and the other is merchandise. The merchandise shop will be open until 6 o'clock today, up there on level 2. You are an Islander EI. My name is Dr. John Griffin, and it is my great pleasure to introduce Christoffer Jerkeby, a consultant from Sweden who works for F-Secure. I've asked all of the speakers I've introduced for something interesting to say about them in the talk, and his was very interesting. He wanted everybody to know that he collects vinyl records and that he DJs at parties using those vinyl records. And it just so happens that tonight, August 8th, he is available if anybody has a party and needs a DJ with some vinyl records at it. Having said that, the talk today is command injection iRules in you can probably read it on the slide. Command injection in iRules load balancer scripts. Christoffer Jerkeby, welcome to the stage.
Thanks, John. Thanks, Dr. John. Wow, it's bright. Okay, my name is Christoffer, and I work for F-Secure Sweden. I'm a security consultant, and I do pen testing. And I have a team of consultants back in Sweden who are eagerly watching this. I should mention Olle and Pasi initially, who this year was nominated to the Pony Awards and for their research on cold boot attacks in BitLocker. William Söderberg helped me set up this presentation and the demos you're going to see, and Jesper has given me moral support, and thank you for turning over to the light side. I've had a lot of support from F5 during this, and I've reported a lot of bugs in my past, and F5 has given me the most or the best response ever so far, and I'm really impressed by that. Thank you a lot for that. And thanks for being here. So we offer consultancy services around the globe, and I'm really happy to have had the support from almost all offices in one way or another during this research. And thanks, you guys, everyone who has been supporting me. So load balancers. F5 BigIP devices are way more than load balancers. And I'm not here to advertise for a product of another company, but I have to say it's an advanced piece of equipment that can do a lot of things. And I'd call it a gateway, I'd call it a session manager, and also a load balancer. So what does the load balancer do? Imagine you have a lot of traffic from the internet going to your backend services, being a HTTP service, for instance. Managing a lot of traffic is expensive, and it's hard to do with one given service, and especially if you have a complex session setup. Let's say you have an intranet or something. Then that intranet will have cookie support for managing who's logged in or not. And also, this device will manage that for you. It will also manage the TLS sessions and host your TLS session keys and synchronize between itself. And I think it's a pretty awesome product that has handled a lot of load throughout the years, and it's pretty stable and really cool. So I'm not here to flame this product at all. That said, there are weaknesses in all products, and it's all about how you react to them, right? These vulnerabilities are pretty serious, and they're hard for F5 to cope with because these are in user-supplied configurations. And I'll show much more about that throughout this presentation. So iRules. iRules is something that belongs inside of this load balancer device that defines where the packet goes. Does it go to one backend server or another one? And how do you define that? Yeah, you set up a bunch of rules saying that this packet has a header with a valid cookie, so it goes to the logged in page, or it has something invalid, so it doesn't go anywhere, or it goes to a logout page or something. And that's a thing you want to do inside of the load balancer before hitting backend servers, because sometimes you can have denial of service attacks. You can have a lot of things happening that you want to filter out already in the load balancer. And those scripts can become pretty complicated. In this case, we have a really, really simple script that we're looking at, and that's a caching iRule. And this rule checks If a request contains a get line looking for the favicon file, that's a file that's the icon file in a request. If it contains that, then it would just respond with the favicon file without even consulting the backend web server. And this feature is pretty neat because that's like a useless load for a backend server, and it just presents a unified front with the logo to the web browser. Okay? And a more complex example is if you have localization, for instance. Here's a GET request that's asking for the index page. And you could have a forwarding script that goes to different backend servers depending on whether it's a request that comes from a Spanish browser or another browser. And in those cases, the backend server will reply with a localized linguistic server, a response back to the browser, so that you can have a localized website. And this is also a very nice feature, obviously, because localization is always a tricky issue. And the reason why I mention this is because there's always an interaction between the load balancer step and the backend server. And this is the way of the flow. And now you're starting to get the idea what the product does, I guess. Okay? So I want to talk about iRules, the language iRules. So back in 2001, the version of TCL or TCL was released called 8.4. And this version was used to fork off and build iRules. And the product has been building on it since. And iRules introduce a bunch of simplifications so that scripts don't have to be as complicated as these ones. In this case, what you're looking at on the left-hand side is a typical TCL script that would not be a valid iRule because it does file operations. This is a common program that tries to translate file endings or line endings inside of a file from the Unix type file endings to a DOS type file ending. And this is something that would not work inside of iRule because it does local file stuff. And the reason why this is blocked out is because you don't want customers to break out of the iRule environment and take over the device in the first place. And it would just complicate things. It would break things, and it would, yeah. So to simplify the language, they're basically excluded, okay? TCL is return-oriented programming, but it also has exception handling, which means if an exception occurs, you can catch it. This is something that can really, really ease up the situation if you're in trouble with this kind of injection. I'll try to discuss that later. So here's a simple script. It does a redirect, a HTTP redirect to a page called Hello World, and it has an event called when. When is actually a command, and HTTP request is an argument. And then there's the third argument, which is the curly brace that opens up for a body argument with a HTTP redirect function, okay? I'm going to go through the syntax of this language a lot because this vulnerability and what we're talking about here has to do with syntax. So we need to understand the language in order to write the files. And I'm thinking the people who are watching this on YouTube later, they will want to learn this specifically because you want to write secure code. If you're a pen tester or if you are a bug bounty specialist, then you will be wanting to looking at for this, the yellow marked server header. This is the HTTP response header that you normally find in a file like the favicon file. It's presented every time there's a HTTP : redirect. So the code we saw before is redirecting to hello world, and it looks like this in the response. And it's a server : BigIP because the BigIP responded to your request. And this indicates to an attacker that this is a BigIP device, and that's something that you as an attacker might be looking for, essentially. We did this with every HTTP server in the world that we could find, and we produced this beautiful map. So this is the planet we live on, and I want to use this map to emphasize the gravity of this because this is a very popular product. A lot of people use this, and the colors you're seeing is responses we got from a request to the favicon file when we tried to reach that HTTP server where it said BigIP in the answer. And there's a lot in the US, but there's a lot in the Europe as well, especially in Germany, and it's big in Japan. These devices protect and serve web requests of different kinds to organizations worldwide, essentially, as you can see. And there's loads of them, which means there's loads of iRules and loads of configurations and loads of complexity. And that means it's very hard to make an outreach, even for F-Secure and F5 combined, to reach all these people who are doing this and tell them this is how you write the correct rules for these, okay? So let's talk about syntax. Tickle or TCL. Tickle supports argument substitution. That means that the arguments are being handled by the interpreter prior to execution. That's a nonsensical sentence for a lot of people here, so I'm going to show some examples. Usually in a programming language, when you write a string, you surround it with quotes. Number one line here shows quotes. In Tickle or in iRules, you do not do that. Because if you surround your strings with quotes, you also make that line executable. I'm going to explain that in much detail later. If you surround it with brackets, that's the hard brackets, you make that line executable. You make that into something that will execute. If you surround it with braces, like the one you got on your teeth, or these guys, then you have a string. So number 3 is the correct way of handling strings. And this is important to remember. Every time you're handling a string, do it inside of braces. And you can also do unquoted arguments, which is an argument to a function, like the command here, that does not have any of these. And that can end up in various states. Sometimes it's safe and sometimes it's unsafe. And I'll try to give examples of when it's which. And it's kind of hard to keep track of, so use braces when you can. So what happens if you have quoted evaluation? There is a document called the dodekalogue, and it was written in the 90s from the developers of Tickle when they started defining the language. And it's the rules of substitution. It's the rules of how the language is supposed to be interpreted. So initially, a script is running and it's being parsed. And the first thing it looks for is the command, which is the first word on the line before a space. And then you have the argument, and the argument here is quoted in this example. If there is a quote around the argument, then the Tickle interpreter will replace the content of that argument with something. So if the content contains a variable, that variable will be resolved. If that line actually contains an executing thing like the hard bracket we just saw, number 2 in the list, then it will execute that prior to running the function that it arguments to. So inside of braces, inside of brackets, if a word contains an open bracket, then the Tickle performs command substitution. This is exactly what happens when you do backticks in Bash. I think that makes more sense to think of in that way. So as an attacker, we want to use brackets, and we want to look for cases where quotes are used. So Tickle injections essentially is just like when Bart Simpson calls up Mo and asks if Al is there, and he says, Al who? Yeah, you know, the Al named alcoholic in the last name, and he's, hold on, who's alcoholic? Is there any alcoholics here? And everyone laughs, because obviously everyone's an alcoholic in his bar. And that means contextualizing something that he doesn't really understand the concept of it yet, but once it comes together, he realizes that he's made a fool of, and everyone laughs at him. So what happens if you have unquoted arguments? This is an interesting case because unquoted arguments can be treated differently by different functions. Functions here are called commands because this is one of the first script languages. If you have number 1 line here, there is after. That's like sleep in any other language. It says waits 1 second and then it runs whatever is in body. So if body contains something executable, it will run it or provide a syntax error. While is the same thing, it has a body argument, so every time you do a while loop, it goes on forever, in this case while 1, then it executes body forever. If statements can be tricked into executing something as well, and switch statements and so on. I'll show a full list of those later. But now you know that there could be body arguments to something, okay? There could also, in the body argument, you could also have quotes. So in this case, this is a prior art collected from the Tickle wiki. This has been around for a long time, but very few people have read it, and this is why I'm here to inform you, okay? If the argument to catch, which has a body argument, catch is catching exceptions. If the body argument to catch is starting with quotes, then those quotes will be, or the inside of those quotes will be command substituted, and then catch will execute whatever is inside there. So the order of things, what's going to happen when this is running, if I set variable to error, which is a function or a command, and it has the argument pwned, this will happen. So the interpreter will, instead of running catch, will first replace whatever is inside of the quote. So it will replace variable with hard bracket error pwned, okay? And then it would actually execute pwned or error pwned and type pwned on the screen prior to running puts and catching the error, which is a bit confusing to some. And I've seen exactly this line, catch and then quote, in a lot of scripts out there. Because in iRules, there's a community. Then you go to a site called devcentral.f5.org.com, sorry. That's pretty brilliant. It's an open community. Everyone helps out. But sometimes people provide examples that are dangerous. And this can always happen. You know, that happens on Stack Overflow as well. But we need to talk about this now so that people actually start informing each other of the problems you can run into if you do this. On Dev Central, you can download a lot of code snippet examples that people are using when they get started with this. And a lot of those examples contains exactly that, catch, quote, something, which is very, very dangerous because anything inside a variable, if that's user controlled, can lead to execution. Here's a list of functions or commands. This is the list of commands that has body arguments. And all of these do some kind of evaluation of what's running. And essentially, this is the majority of the language in the end. I might be missing some, I might be having added some that are wrong, but essentially these are the ones that has body functions that I could find. And all of these, you have to take care to look at the arguments and not use quotes in the arguments of any of these, because that means execution, okay? Sometimes it can also be dangerous to not use any quotation at all, because if you have, like you saw before, an argument without quotes, then it will lead to execution as well in the body. Then there's these three guys. Everyone who is at a hacker conference usually knows that eval or evaluation is dangerous. Eval is a function that actually just evaluates whatever's going on and executes it. It's dangerous, but people still do it. So let's talk about that. Eval could be said to be evil. You can probably avoid using eval, and you can probably be good without it. Subs does substitution. It's actually a safer way of doing the same thing, because in subs you have an option that says -no commands, and that means that whatever is in the arguments, it will not look for hard brackets and it will not execute the code in there if you do the argument -no commands, okay? Expr is a function you cannot live without, because expr is math. Expr is where you perform addition between two things. So if I want to add 1 + 1, I do it with expr. Expr means to do any type of arithmetics. And expr also does command evaluation, because in math you need to figure out what's going on before you can add something. So you need to actually run the functions in the argument list prior to making the math, essentially. And that's an important piece of information there. So expr can be very, very dangerous too. Here's the script. I want to show you some coding examples of how it can go wrong without us knowing it. So I'm using an open source snippet called the HSSR. It's a guy called Mark did a hyper super sideband requester. That tool is used to do client requests to backend servers. It's pretty awesome, and it's the most downloaded piece of code that I've seen. I think it's the most downloaded piece of code on Dev Central, which means it's the most popular open source snippet there is in this community. And it's slightly vulnerable. And I'm using it as an example because they have some kind of defense mechanism that I'm going to soon. So what's happening here is that you're running set status, and you're calling this function essentially, and you're putting the URI in there. URI is derived of exact language, which is a header that the user can set. So the user can say, instead of en-gb or something, that's your linguistic preferences, they could set it to something malicious. That would go into the URI. HSSR layer does this. There is a highlighted line here where it's trying to do a NS lookup or a DNS lookup of the hostname part of that URL. If you do that like this, here's an eval that then quotes. That means that the content will be resolved inside of the hostname that the user now controls because it's in the accept header. Then execution will occur when the eval runs. And the user does not even have to write a hard bracket to perform execution because they're already in the line of execution, which means that all they have to do is type semicolon and then just continue write tickle code as they want, and they're inside of the device. The reason why I'm showing this piece of code is it's actually not vulnerable. Prior to this, there is a regexp that filters out unwanted characters, which means that essentially it's sanitized in a way. You can make this line break, you can make the script fault, but you cannot make it execute. And that's why I want to show this particular example. I tried to be responsible about this, okay? So, exploitation. What you have to do as an attacker to do this, and also as a defender, I guess, is identify the fields that are going to be used and substituted by iRule. So imagine that you're an organization that's actually using iRules. Maybe you actually want to make a list of all the valid user inputs and see where do they go. If you make that list, then you have a better chance of defending yourself against this type of attacks. Okay. So as an attacker, you want to inject tickle code or iRule code into a request in any type of field that you can think of and see if that code is actually running, coming back to you. And after you've done this, you try to identify any other type of external resource that I can pivot to get permanent access into this, okay? Here's the video, see if this works. It does. So here's the HTTP request. On top you see a regular web browser, this is Internet Explorer, and below you see Burp. Burp is a tool that's essentially acting as a proxy, and now we can make changes to the request before we send it to the server. So here's a few headers that's interesting for us to look at. There is the get line, the HTTP version number, there is the user agent we just passed, there is the accept language that we exploited in the past, there is the accept line, which looks at what type of requests or what type of responses we accept, etc. And there is plenty of injection possibilities. We don't know now as an attacker what is vulnerable or not, but we can get a hint. So there is 2 cookies being set in my client. My client has 2 cookies. If we look at the response, it's actually trying to set the word logged out into the Yay session ID, and this is a suspicious thing. So as an attacker, what I want to do now is to send this request into the repeater in Burp. And I can't tell you enough how much I love this tool, but that's not why I'm here. So if you select this line with the Yay session ID and you actually replace that cookie value with a valid iRule line, here I'm using hard brackets because that means execution. I type TCP : respond. That will make a response prior to the HTTP header being sent. And I use braces, is it correct way? Then all of a sudden, ta-da, you see hello being executed there. See, hello is actually coming prior to the HTTP request. This means that I'm in control of what's going on the BigIP device right now for my request, okay? I can also run a function called HTTP respond. Right now I'm getting the syntax wrong, but usually that's not as effective as TCP respond because HTTP respond can only be done once per request. And if someone else is already doing it, I can't do it twice. It will produce an error message in the log, and someone can actually detect that I'm trying to hack them. As an attacker, I don't want to do that. So I'm using TCP respond, which always works. And this gives me a safe way of defining or determining if an input field is validated or not. There is a command called info level 0. As an attacker, it's a brilliant command because it gives me the source code of the current context I'm in. And I don't even know what to compare that to. That's a leftover from Tickle. I think that F5 could actually remove that command without harming anyone. Here you can see the line that's dangerous. I highlighted it now. It says subst cookie might be vulnerable, and it does substitution on that. That's the dangerous line there. I think, if you just review code like that, it's pretty hard to determine what line is vulnerable unless you know something about this. You need this information that I'm giving you right now in order to protect yourself, because I see flaws everywhere now that I've started to look at it. So how do we take it further? As an attacker, you usually want to elevate your access, maybe or maybe not. How do we actually get persistent access in this? Right now we're in memory, so we're inside of the interpreter, which means it's pretty hard to detect us. There is logging, optional logging that the user can use or not. It's a function itself. an attacker wants to not be in the logs, I guess. To become persistent in memory for a longer time, there's something called table. And table is used for synchronizing a key value store. So imagine you have a bunch of cookies and you want to store them in memory and synchronize those between devices. This is one of the most profound and awesome features with BigIP products because they're always synchronized and it somehow magically always works. And once this is synchronized, as an attacker, it's also interesting because that means I get access to all instances if I can use the session table or inject into the session table. The session table syntax looks like this. You can set, lookup, add, replace. That's the things you would probably want to do. And that means if I, as an attacker, have an injection in a code that actually uses table anywhere, then I can inject into that table and actually put code there that will execute once that user logs in or does something. So let's say I have a user called admin and I want to get that user's account. Either I'll just steal the cookie by doing a table lookup admin and get that cookie. I could probably do that. Or I'll replace the admin cookie with more information that I want to use as an attacker. This example I'm going to show now is a little bit complicated, but I'll try to walk you through it as we go. This is a service that does DNS lookups for you. And once you do DNS lookups twice, it's actually caching them, so you don't have to do DNS lookups many times. And I've stolen the line from HSSR that does the DNS lookup. Just so you have an example that actually works. So as an attacker, I already know now that this is the field I'm looking for. And I'm doing URL encoding, that's important. URL encoding means that it's replacing the values with hex here. And now it's trying to make a DNS lookup on an empty string because that's what's returning from a TCP : respond test. And that takes some time, so bear with me. And yeah, so different values need to be encoded differently. This is a URL encoded value because it's on the request line. So test is coming back from the server. That means that we have an injection point. The next thing we do is to check the syntax or check what kind of script we're running here. So we're doing an info level 0. Now you're learning how to start building an attack, I think. Info level 0 gives us the context of where we are. And as always, the response takes time because now it's doing a DNS request of something empty in the background, which is not a quick thing to do. It takes exactly 120 seconds. Actually, I forgot to press go there, I think. The timeout of request is something controlled by a backend feature that we will look into more later as well. There we go. So info level 0 should give us a full list of the source code running on this device. As an attacker, we want to know what the code looks like because we want to exploit it further. In this case, I'm scanning through the code for eval because I happen to know that eval is the keyword for the bad thing. But as an attacker, you also do code reviewing here. So you're reviewing what's going on. And you see that there's two evals. One is on the response from the table lookup, and there's one is from the resolve line. That's the one below there is the one I stole from HSSR. And the one on top is the one that's looking for the cache. It's looking for the cache and it's picking up a value. And this means, you don't have to understand all of this right now, but this means essentially that I can inject something in both eval cases. So once it's doing eval on the content of something on a table, so I can inject something that will execute when someone else looks in the cache. That's the same as overriding someone else's cookie, for instance. And since the injection point is inside of quotes, then I can simply write semicolon in the beginning. And this is why it's so hard to do input sanitization. Like usually you do input sanitization by saying, oh, let's remove all bad characters. There is a lot of bad characters here. Or the first one would be a space, a semicolon, or a hard bracket. That's the easiest. So we're looking for localhost, semicolon, and then I'm just writing the line as if I was in the tickle file, okay? And right now I'm writing a line saying table set dash subtable cache. So I'm overriding the cache. I know what it's named because I know the source. I'm using the value localhost, and for the low value localhost, I'm doing a TCP : respond owned. So that's something. I guess it could be doing XSS or whatever, or something else. And then I select that line and URL encode it eventually. So that TCP respond will be running in that eval that I'm selecting there. Okay, so now I'm running it without URL encoding it. That's not good. This will produce a syntax error in the device. As a defender, right now, if you're looking into your log files, your CM system, somewhere it will say syntax error. This is an indicator of an attack. If you make CM entries and look for syntax errors, then you will actually know when people are successfully or about to successfully inject code into your device. And that's something that's very good to do. So right now I'm poisoning the cache by adding executable code into the value of localhost. And right now it just sets the string that it's going to run later. And the next time I make a request to localhost from the cache, it says owned. And this will occur to anyone who tries to make a request on localhost. And this is how you become a stored man in the middle. This is a man in the middle essentially because I'm stored in memory and I'm man in the middle on other people's requests. So that's one attack vector for getting persistence. There's something interesting about this piece of code, because if I take this piece of code and I put it inside of the code viewer in my BigIP web interface, there is something going on line 17. Then you see it's very colorful. I don't like reading text, I like colors. But line 17 is very colorful. It says eval, table, lookup, dash subtable. All this is written with colors. If you look at line 21, it says eval and then quote, and everything is blue. And this indicates to me that the person who wrote this syntax highlighter does not completely understand the language, because the moment you're using a quote, it's exactly equivalent to using hard brackets. They should be colored the same way, so that you actually understand that this line is not safe. This is executing something. It's dangerous. This is my 5th descent on the colors there, but yeah. So other post-exploitation possibilities, where do you want to go from here? Scanning the internal network, yes, you want to do that, because now you're having some kind of a man-in-the-middle situation. You want to scan local host, yes, you want to do that because there's services running locally. And you want to attack internal resources using the F5 BigIP device as a pivot. And here's a print screen of a command called active node list -list lb : server pool. This line URL encoded, when you run this, it actually gives you a list of the internal servers that you are serving, or that the F5 is serving. And this gives you an indication of one of the servers or the server network that you want to actually break into. As an attacker, maybe you're curious about this. How do you connect to this guy? Well, here is a snippet that actually does a port scan on that line. So that's something you might want to copy later from the slides. If you do this for each, it's trying to go through FTP, the web port, and some other ports. And it's trying to connect to this backend ports, and it's listening if it's open or closed. So this is essentially a one-line, or two maybe, one-line port scanner that it turns into. So now we know something about the background device here. Imagine, like it says port 21, it's FTP. That's usually not very safe. So as an attacker, I'm implementing my own FTP client, obviously. And this FTP client now does an anonymous login. And that means receive 2 lines, which is the banner lines, and the login prompt. You type in user anonymous, the password A, and then once you're logged in, it actually says on the right-hand side, 230 user logged in. And if you are a bank and you're running this device, make sure to firewall it so it's not possible to do this type of connection, because specifically for banks, they use mainframe machines. Mainframe machines are usually controlled or sometimes controlled over FTP, and that's something that could be very dangerous if that mainframe computer is exposed. Hope that makes sense. So here's the attack chain, what it looks like. I make a GET request, but inside of that GET request, I'm also adding something extra that turns it into an FTP request in the backend. There's an FTP response, and the results are being produced back to the browser. And the attacker now knows that I can log into this FTP or download files. Here's another port scan I did, unfortunately a bit smaller, on localhost. And this is interesting because localhost has some services that are unusual to me. One is 666. I think that's the port for Doom, the game. It's probably not Doom, but there's also one 8100, which is some kind of Node.js service that I haven't investigated much. 66 was interesting to me because that service was running as root. And the service is called MCPD. And this looks weird, I guess. This is a very common command that runs internally once every minute or so. And what the command does is that it makes a query all. It queries everything from the MCPD system module. System module is a very central module. It looks like a bit of a memory dump, but it contains a list of daemons running on the device. Right now, it doesn't do anything useful, but this is the packet that you will pick up if you do a TCP dump on your F5 device on that port. You will see this packet coming over and over again. So replaying that packet is something interesting. It doesn't give off too many secrets. So someone reverse engineered a bit of this protocol, and the results were interesting because MCPD is pretty powerful, running as root and all. This is the result of the reversing. So there's a size indicator, a sequence that it doesn't seem to care about much. I don't know exactly why, but you can put any value there. Request ID, always set to 0. Flag, can't exactly remember. The key is what type of request you're making. If you're making a query all or query something specific or execute something. You can execute things here. Actually, I think that the web interface that you manage this device over communicates with the backend service using this language and the queries that it's making. When I'm clicking around the web interface, I see all these packets coming, and they are doing different types of queries, and sometimes they execute commands. There's a type field, an attribute size, that's a size 12, the coming bytes. The attribute name, which is interesting because there's a bunch of modules. I think there is more than 1,000 modules, maybe not so much, but it's like hundreds of modules that you can query and get different information out of. And I'm going to give a few examples of that. And then there's attribute data. If you're making an execution, then you're doing this. And essentially an end of message. This to me looks a bit like the SSH protocol. I'm not going to say anything more, but it's very similar. Here's a request to the module that handles all the users. I don't know if you can see this, but on the third line of the hex dump, it says admin. A few lines more down, it says user, which is user. And then it says Willy, which is William Söderberg, who set up this machine for me. And that command that I'm now running as an execution, I'm injecting code into the server so that it runs something, sends a packet to localhost and gives the result back to me, now gave me a full list of the users locally stored in the web admin UI. There's no passwords as far as I can see, but there's that. Here's an interesting one. So here's a command that lists the source code of some kind of Tickle environment. So TMSH is a Tickle environment where you can do backend configuration. Remember I said something about the DNS lookup timeout? That's something that you configure in the TMSH as far as I know. So it's a system running as root with Tickle as an interpreter. Another interpreter than the iRules. This is not the same thing as an iRule. I cannot run iRules from here. But from MCPD, I can run iRules. I can actually change the bit where it says query all to execute instead and run TMSH commands from here. I think. I have not done it, but I think I can. And if you look at the highlighted line on the right-hand side, it's a function called getItem local only that returns an evaluation of something long that I cannot pronounce, and the argument that was supplied by the user is being evaluated. This is a dangerous function, and I'm pretty sure that this can be used to elevate to more privileges, perhaps root, at some point. I know it's vague at this point, and I haven't had time to do the complete research on this, but I think elevation would probably go through some of these scripts. And this is something that I'm trying to work with F5 on trying to fix. Yes, to make this code safe, and I think there can be a lot done to separate the context so that, for instance, a socket cannot even be open to localhost. That would be a pretty good start to avoid this kind of local privilege escalations. So what we're dealing with here is an attack chain where I have first iRule access, I query the MCPD, I get a response, I can execute some kind of MCPD command over for TMSH and do a TCL injection in the TMSH environment. something, something, and then get local privileges. I'm assuming. I think this is an attack path to actually take permanent control of the device at this point. I'm hoping that this will be fixed soon and that there will be a separation. I'm really, really keen on people not being harmed by this. And I'm really, really keen on trying to make sure that people understand how dangerous iRule access can be. If someone else gets access and control of your iRules, they can do really, really bad things to your organizations. They can listen to your traffic, they can inject things, and reroute traffic in ways that you would want to avoid, I think. Okay, so let's go through a summary. We have 11 minutes left, where we talk about detection, because defense is very important. TCL scan is a tool intended initially for scanning for TCL injections in TCL tools. I did not write this tool, but I fixed it because it was utterly broken. It's written in Rust, and it takes a bit of working to get running, but once you do, you can run it on your, if you translate your iRules into pure TCL, which you can with a script I provided in my GitHub. If you run this tool, you get highlights of all the lines in the script that's dangerous or perhaps dangerous, warnings and danger. And that's something you want to integrate into your Git. If you're using Git for version control of iRules, you want to make sure that this tool is running and checking your lines, because it will detect most of the problems you have. And then you can get a bit of a spanking for doing it wrong, hopefully. I have made a tool that's being released today at Black Hat right now. It's available in Burp Suite. If you have Burp Suite, you go to the BAP store, the Burp App Store, and you search for iRule detection. This tool, or iRule detector, this tool will try to replace every single field in a request. If you mark a few requests and you right-click and press send to active scanner, you'll get a report of every type of field that actually can be run for injection that causes the same code to be running back to you. And it's essentially doing what I showed in the slides previously, but much more automated. And so far I found lots and lots of flaws doing this. I just download open source code, don't review it at all, just run it there, and then I run this tool and it just finds the bugs for you. If you're in bug bounty, this is the tool you're looking for. If you are on the defense side, this is the tool you're looking for, okay? So that's available for free for you now. Unit testing. This is a tool I did not write either. A nice Norwegian guy did, and it's called Testicle, unfortunately. I did not choose that name. So Testicle, if you fill it out, it's a tool where you can do unit testing for your iRules. So essentially you put up your iRules, hopefully they're short and easy to read, and you can use unit testing. And this can test your logic in the program, because there's so many bugs that are not related to what I'm talking about that you still want to catch. Like, are there infinite loops? Are there cases where you get a connection timeout? Are there errors, bugs? This tool fixes or finds that for you pretty easily. And that's also something you can integrate into a Git hook when you're doing version control of your scripts. I was contributing a bit to this, adding cookie support and played around with HTTP. When I did, I had a bit of a problem because I was trying out this thing with injections, and this tool does not, it actually has a lot of injections in it. It does eval all the time, and because everyone does, and so it also crashes if you try to do that. Sorry. So, a summary slide, finally. TCL is an old and tried language, but it's loosely defined, which means the position is very important for what you're doing. The quoting is even more important. It's easy to fool for an attacker. It's hard to get the variable assignment and substitutions right. It's very hard to do it right. Read the document called the dodekalogue. Read my white paper released with this. It will help a lot. And I'm also giving a description on how to do code review, because the art of code review is not so easy. But there is ways. You can search for certain things. So you search for eval, you search for subs, and you search for expr. That's the first thing you do. Then you start looking at how are while loops handled, body arguments, how are they handled, that sort of stuff. Take care to use bracing on the body arguments of things. So if something has a body argument, use bracing. Use the iRule detector to detect if there is any injection possibilities. It's pretty competent at this point. I think there can be more features added to it. If you want to contribute, it's open source, just go ahead. You can use TCL scan to review the code and automatically review the code. It can cache everything, so do manual code review and know your shit. And use testicle to try the logic. And if you cannot do a code review, admit it and ask someone else, like me, to do it, or whatever company. Because you need to look at what you're doing. You're responsible. This is an advanced product. You can do it wrong. Don't do it wrong. And if you think you might be doing it wrong, ask someone else to do it for you. That's about my final slide. I'm so happy for your focus and for you being here listening to this, and I hope this provided a new type of tool for your future engagements. Thank you.
To ask questions, there's microphones in the middle of the room. Please use those microphones.
Hey, thank you for your presentation. I was wondering, though, if you've looked at being able to steal SSL certificates through the iRule injection. Are they exposed in that space?
Okay, I did that, yeah. I think I ran an MCPD command once. I didn't document it well, but I did an MCPD command once that gave me the private keys, I think. And there might even be an iRule command to that, but I'm not entirely sure, but
But yeah, you're saying it.
I'm pretty
like
sure you can do it, yeah.
Thank you.
Yeah, thanks. I got a nod from F5.
My question centers around sanitization. It sounds like if you sanitize all your input, you shouldn't trust anything from an external user anyway. If you sanitize everybody, not that you can't apply these also, you should be okay.
Yeah, I think that's a really good way to go. Sanitization goes a long way. Imagine you're sanitizing the user agent. The user agent contains hard brackets. It contains semicolons. Like, you can't take them away because then you're lying about the user agent. So it's tricky. It's like you can do it sometimes, and please do. So, and sometimes you just need to avoid putting things in dangerous positions too.
My question is, can you just use netcat as a poor man's burp suite?
Yeah, for sure. I mean, all this you can do in netcat, and sometimes I actually do these requests directly in netcat, definitely. I guess you could probably port these tools that I put out there to just run directly without having burp in the first place, if that's what you want.
Hey, thank you for this presentation. Did you get to look at maybe the competing products, so A10 and their A-Flex language?
So I realize now I was supposed to repeat the questions. Did I look at competing products like A10 and A-Flex language? I did not. I'm sorry about that, but I tried to focus on this to just get as much out of it as possible. I am looking now, and I'm about to look. And I've started to realize that this is a thing. Complexity always creates problems, and yes, there might be other things there. I have a few research projects awaiting related to similar products that I cannot disclose yet, sorry, but there will be more.
There's a couple more questions. He's good in time. He has 3 minutes left.
If you have a WAF, will it protect your bad iRules? Which one takes priority, the iRule or the WAF?
It's a good question. I tried this with a WAF. I'm not 100% certain, but I think the iRule came first and then the WAF in my case. And also the WAF at this point does not have rules for this type of injections. It's very hard to do in the first place, honestly. But I think the iRule comes first, which means that it does circumvent the WAF, because the WAF is not intended for defending the BigIP device.
Okay, thank you.
Since I can't see you, I don't know if there's any more questions, but welcome to.
Thank you so much for joining the session. If you have further questions for our presenter, please meet him in the hallway area. Thank you.